Okay, so let's start with the very first one. Is it ionic or is it covalent?
Ionic.
Okay, so we're going to put an I by it. Okay, the next one, ionic or covalent?
Covalent.
Okay, the next one, ionic or covalent?
Ionic.
The next one, ionic or covalent?
Ionic.
Ionic or covalent?
Covalent.
Ionic or covalent?
Covalent.
Ionic or covalent?
Covalent.
Piece of cake, right?
No, how you know, teacher? I don't know.
Okay, so anybody want to help him out? How would you know that it's ionic or covalent? Easiest way.
Is it from like distinguishing for ionic? It's from like a metal and a non-metal formed together.
That is correct. So if we have a metal and a non-metal, it's going to form an ionic compound.
So you have to look at the chart here. It's like, you know, like it, you know, let's say the first one, A.
Okay, hold on 1 second. Let me get my P table up.
AL.
Then you can explain to me what you're saying.
Okay. And
Let me switch my screen.
that one is covalent, that's why.
Okay, so now what were you saying? I have my periodic table up because that's what I'm going to use, right?
Okay.
Okay.
So positive ion is carbon negative.
Ionic compounds are going to have metals and non-metals, right? If you have a metal and a non-metal, it's going to be an ionic compound.
Oh,
If it's just non-metals together, it's going to be covalent.
covalent. Okay. So it's basic on the metal and non-metal. So it's a non-metal with metal can be like ionic.
Ionic, yep.
Okay, covalent is non-metal.
Yes, covalent is all non-metals. Okay, so let's take a look at the questions that we have.
Okay.
Okay, so here, carbon, hydrogen, oxygen, hydrogen. You look on your periodic table, are those all non-metals? Or are they metal and non-metal?
CH, come. CH and OH.
So you look at carbon, hydrogen, and oxygen. Are they metals or non-metals?
Carbon is just the one H, CH, helium. Hydrogen is a metal.
No, hydrogen isn't a metal. Look on your periodic table.
They are white color, teacher. It's a white color.
So look at your periodic table. It tells you. Pay attention to the color it is. It tells you if it's a metal or non-metal. It has N next to it, right? That means it's a non-metal. You see that N next to it? Here, let's go to P table again. Okay, look, are you looking on the screen?
Oh, okay.
Okay, look on the screen. Hydrogen, when I put my finger on hydrogen, what happens? What lights up? Take a look. What does it say?
It's non-metal, it's green.
That's non-metal. So then what is it?
It's a
Covalent.
covalent.
Covalent. That's right. If I put my finger on carbon. What is it? What is it?
Covalent too. It's non-metal.
So it's important that you learn how to use your periodic table. It tells you all of that information on your periodic table. So pay attention to your periodic table. It gives you all of that information up here. Can you guys see my, let me stop sharing really quick.
No, I got it. I got it.
You got it?
Yeah.
Okay, good. Okay, so. Okay, so we know how to distinguish between covalent and non-covalent. I mean, covalent and ionic. Piece of cake so far?
Yeah.
Okay, so we'll save the Lewis dot structure for last because we're gonna have a lot of fun with that one. Okay, over here. So what is gonna be the compound that we're making? So the first one, this one right here, B 4 plus and 3 minus. Anyone gonna take a gamble?
4 plus and 3 negative. Let's see. V.
I'll take a guess, but I think I'm wrong.
Okay.
But would you combine V and N,
Okay.
and then you need the Lewis structure needs to be total to 8?
Don't worry about the Lewis structure. Just tell
Okay.
me how many V's am I gonna have and how many N's am I gonna have to balance it out?
Would
Is
you
it
need,
balanced?
I don't know.
Covalent. Ionic. Covalent.
You cross multiply?
Ionic.
You're gonna have to cross multiply. So how many V's are we gonna have?
3.
Okay. And then how many N's are we gonna have?
4.
Simple, right? So if we look at it, it has to equal 0 at the end. An ionic compound has to be neutral, right? That's the most important thing. So it's just simple math, right? It's adding and multiplying. How many V's do we have here?
3.
Okay, so again, when we were looking at a chemical compound, the number, the subscript that's next to it tells you how many you have. So if you have a 3 after it, that means you have 3 of those. So you have 3 of those ions. So 3 times positive 4 is what? That equals 12, right? So we have to have a negative 12 to balance it out. Do we have a negative 12 to balance it out? We have negative 3 times 4. What does that equal?
Negative 12.
Oops, sorry. So it equals negative 12. Does that equal to 0 when we add them together?
Yeah.
Okay. That is horrible. Horrible writing. Okay, so again, ionic compounds have to total a 0 charge. So they have to balance each other out. So now you guys should be able to help me out, right? Should be easy. Okay, what about this next one?
So this one's going to be V2 negative O 4 plus.
Would it be V2 negative O4 plus? Is that the lowest common denominator that we could have? Or lowest common number that we could have? So in this case, do you need to cross multiply? That's what I'm asking.
No, because you already have a common denominator,
Okay, what would be the common denominator in that case?
4.
Okay, so if we're doing 4, this is already 4. So how many of those are we going to need?
4.
We're going to need 4. If this is already 4, we're going to need 4 of them.
0.
because you already have 4.
Okay, so I would need how many? 0?
2.
One.
0 meaning that you don't have it at all. That's what 0 would mean.
1.
2.
1.
2.
4.
Okay,
4, and then you multiply oxygen by 2 to make it -4, and then it.
okay, so you're telling me, wait, I'm going to write down what you guys just told me. I'm going to write down every one of the cases that you guys have. The one person says it's 4. One person says it's 0, which means that it doesn't exist. So there's nothing there. And then I heard one person that says it's 2. So then that would be V2. Okay, so those are all of the ones that you guys have given me so far. Okay, so then how many oxygens do I need to sit there and balance it out?
2.
Okay, so you're saying O2 to balance this one out? How many do I need to balance this out? Are you there?
04.
Okay. Okay, so this would be the case that we cross multiplied, right? This answer would be totally wrong. And I'll tell you why here in a second. This answer, although it does equal 0, this answer is also totally wrong. Okay, so let's pretend, just for simplicity cases, let's say instead of using a V, because this is the problem that you guys are having, instead of using a V, let's say we have 4. Okay, just use the number 4. Instead of using an O, let's just use the number -2. So even though we say 2 minus, let's just say -2. Okay, so you're saying 4 times 4 plus -2 times 2 equals 0. Is that true?
No.
Okay, what does this equal? I want you guys to do the math for me, because maybe, you know, I learned math a long time ago. It may have changed since then. So 4 times 4 is what?
15 of it.
16.
16.
Yeah.
-2 times 2?
-4.
-4.
4.
So last time I
12.
did math, 12. Is that true?
Yes.
Okay, good. So we can establish that. This does not equal 0. So is that balanced?
No.
No.
Okay, good. Okay, so we know that this is a crazy number. Okay, so in this case, here we have V2, O2. So is this the lowest possible that we can actually have of that V2, O2 combination? Or is there something better? If I have, let's use again, if this was 4 times 2, it works out. I'm not going to say it doesn't. Plus -2 times 4. So that equals 0. But is that the lowest possible one that we can have? Is there something lower? Can these guys be divided into each other? Can 2 be divided into 4?
Yeah.
Yeah, it can. So that's not giving me the lowest possible that I can have, is it not? What would be the lowest possible that I can have? If I can divide 2 into 4, how many V's? 2 divided by 2 is what?
1.
1. Oh, 1.
2 divided by 4 is what?
2.
So VO2. So let's do that math. So V is 4. So 4 times 1. 4 times 1 is what?
4.
4.
Okay. And then over here we have -2 times 2. -2 times 2 is what?
-4.
And that equals?
0.
Oh, wow. Imagine that. Pretty simple. Piece of cake? Are you guys even there?
What's this called, Dr. Henry? What is this
Yeah.
concept called?
This is called it's balancing the formula, right? So it's not balancing the chemical equation, you're just balancing the compound itself. So you want to make sure that compound has a neutral charge. Anytime you have an ionic compound, it has to equal 0. And you want to have the lowest number to have it equal 0. Okay? Because really, this here is a different compound than this. Okay? And so you want to always start off with the lowest possibility because that's what's going to form initially. Okay? You guys are there with me so far? Okay, let's do the last one. I guess not. Last one.
The Valence formula need to be 0.
So the overall formula, it has to equal 0, right? So here we're saying V is the transitional metals. It can be any plus, so it could be +1, it could be +3, it could be +2, it could be +4. It could even be +6, right? But right now we're saying it's +4, okay? So, and now we're working with fluorine. So what would be my formula in this case? Okay, if you guys don't start answering, I'm gonna start getting upset. You don't like me when I'm
VF4.
upset. What was that?
VF4.
VF4.
VF4. Okay, why is it VF4?
So it balances.
Because it balances, right? So if we assume that the F is going to represent a -1. You're saying I have 4 times -1.
Equal.
And then here we have one of these, right? Because that's an understood 1. So it's 1 times 4.
4.
1 times 4 is what?
4.
4.
Minus
-1.
oops,
Equals 0.
equals 0, right? So it's balanced. It's 0, it's neutral. Questions?
4 times 4 is 4. 1 times 4 is 4. -1 times 4 is -4. So
That's right.
the negative become a positive?
No, did it become a positive? Look at this. 1 times 4 is 4.
Uh-huh.
-1 times 4 equals -4.
How about the negative side on top, on the middle?
What are you talking about? I don't understand.
No, the positive side on the middle.
This here?
Yeah.
So if you have a positive and a negative next to each other, right? So this is kind of like saying a +1 times negative.
Oh, got it. Yeah, got it.
You got to remember that simple math. Remember when we talked about that simple math? This is just simple math. So don't make it harder than what it is. And this is what
Dr.
most
Henry?
students do. Make it harder than what it is. Yes.
Can we try another problem?
We can try tons of these. You want to try another
Okay.
one?
Yes.
Okay.
Yeah, my brain
Yeah.
is kind of slow. I'm not really participating, but I'm trying to
Okay.
pay attention.
Okay, so things that make me a little upset as an instructor is if you're not asking questions or if you're not answering, if you're not participating, that makes me mad, okay? And then when I get mad, I make really hard questions for the exams. So I'll put a whole bunch of these on there that'll be really fucking hard because I'm like, they act like they know it. So then, you know, if you ask me questions, if you slow me down like David did, it's better because then that way I can get an idea of what you understand. I may sound condescending, but it's important that you learn the information. You gotta get a tough skin, you gotta deal with my little, and all of that stuff. Get over it, don't worry about it. Ask the question. Don't be scared to ask the question. I get mad at you when you don't ask the questions and then you fall behind, okay?
Dr. Henry, please, sorry to cut you short before you continue.
Okay.
This that we're talking about now, is it concerning the problems you just gave us to solve a while ago?
Yeah. Yep, I just gave you. It is concerning the stuff that we've talked about this already. We talked about it yesterday, and I know it's just a day, but that means you got to stay up with me, okay? So let's try it one more time. You guys ready?
Yes.
Okay, good. So let's say we have this transitional metal. If I'm eraser. And the key is, these are some of the fundamentals of chemistry, understanding how to write the formula and understanding how to tell me what the formula is. But if you can't write it, how can you tell me what the formula is? Okay. So let's say we have this one. We have, let's see, we have, okay, so we're going to use iron for all of these ionic compounds. Okay, there's a couple of ways that we can think about it, right? So the simplest way to think about it is to say iron, because you guys are getting freaked out by that Fe, right? You're like, iron, just put it in mathematical terms. What is the charge of that Fe?
6.
So it is a positive 6. Okay, and then what is the charge of the C?
-4. 4 negative.
Okay, so we're just going to say -4. Okay, so we want to figure out X times 4 plus Y times 6 okay, is equal to 0. So how many of plus 4s must we have, and how many minus 4s must we have so that it equals 0? Okay, so that's what we're really doing. Okay?
Okay.
Okay. So what was that?
Okay.
Okay. So the best way of doing it is to look to see if they have a common denominator, right? Or they have something in common, right? In this case, do they?
Yes.
Okay, what is it?
12.
12.
12. Okay. So then for them to equal 12, what do I need to multiply 6 by?
2.
2.
Okay, so then we're saying y is equal to 2. So then we have
Next would be 3.
12, and then x is 3, right?
That's 3, yeah. That's it.
Okay, so then we have 12 plus negative 12. Does that equal 0?
Yeah.
Yeah.
Okay, so then that's real simple. Then you put f so that we said there's going to be 2 of those. So this is like saying here, this is that little y,
Um,
and then this is your little x. Okay, so then we say f is 2 and c is 3. Piece of cake?
yes.
Okay. So you want to confirm that, right? It's always best to confirm it. So if I have 3 C's, each of them are plus 4. I'm running out of room. Let me put this over here. I have 3 C's. Each of them are, 4 minus. And then I have 2 F's. Each of them are 6 plus. Fe, not F's. So 6 plus 6.
Oh.
How many?
12.
12. Okay. And then 4 minus 4 minus 4 minus.
Negative 12.
Okay. Does that equal 0?
Yes, it does.
Yes.
Okay. So then that confirms my equation, my formula, my chemical formula. Okay. Piece of cake?
Mm-hmm.
Okay. Now that you guys are feeling more confident with it, what I want you guys to do is I want you guys to finish this up in groups, and I want you to be able to explain it to each other. Then come back and explain it to me, okay? Because this is important. This is the fundamentals of chemistry, right? So you're seeing how things are starting to build on each other?
Yes.
Okay, you guys are ready? I'm going to send you back to your groups. Slap you around a little bit,
Let me take a picture.
okay? Are we ready?
Yeah. I think so.
Okay. So we'll start with group 1. That is going to be Karina, Jamie, Kayla, Selena, Siobhan. So you guys let me know about iron oxide, or the iron 6 plus and the O2 minus.
Okay. Do we just use annotate into it or?
Yep.
Okay.
And then I want somebody to explain it.
I can explain it. Do I just write anywhere, Dr. Henry?
What was that?
Do I just write like anywhere on the whiteboard or?
Yeah, you can write anywhere on the whiteboard.
Okay.
Anywhere that you find space. You want me to erase the carbon? Let me give you some room.
Yes, please.
Okay.
And I explain it, Dr. Henry, as I'm drawing it, or
Yes, that would be the best, because then
Okay.
we could see it in action.
all right. Let me just put it right there. Plus and okay. So what I did was I found a different way of doing it.
Okay.
So what I did first was that I tried to balance the charges, right? So on iron, I have a 6+, and O, I have a 2-.
Okay.
And I know that in order for the O to have a 6-, you would have to have 2 of those O's, right? So you would have 1, 2, and 3, right?
Okay.
And if you add these 3 charges together, you get a 6-
Okay.
charge. And what I did is, since you have a 6+ and a 6-, this charge cancels out and all these 3 charges cancel out. And all you have to do is you just have to write down what you are left with. So you only have one Fe right here, so you would just write Fe. Oops. And then you have your 3 oxygens right here, so you would just write O3. And that's it, basically.
Okay. Sounds good. Anybody disagree? Everybody agree?
No. Yes.
Okay. Okay, group 2. Let's see.
FB.
Group 2, you guys are gonna get Fe 6+ and N3-.
O. 3. So the final answer is FeO3.
That's correct. Okay, who's gonna be my volunteer? Or do I have to volunteer somebody in that group? For group 2. Oh, it's Andy, David, Guadalupe, Leslie, and Rachel.
David, go ahead, David.
Okay. So for, I have to write it down, don't I?
Yes, you do.
So for Fe 6+, we want to equal it to 0 with nitrogen. Hold on. I can't multitask. So to balance out Fe 6+ and N3- is you would need another N3- to balance out the F 6+. So if you add N3- with another N3-, it'll be N3 6-. And then if you combine them all together, it'll be Fe N2 to balance each other out and equals 0.
Okay. Do you guys all agree with that?
Yes.
Yeah.
Okay. And let's see, group number 3. That would be Jamila, Jessica, Joanna, Jocelyn, and Matt. You guys get the last one.
Any takers?
Or do I have to volunteer somebody?
I'm doing it.
Looks like somebody's working on it.
Okay, good. Okay, so that is almost right. The only thing is that you want to write it a subscript, not a superscript. Because the superscript means something different, right?
Like that?
That is correct.
Can you explain that, Dr. Henry, why it goes on the bottom?
Because you're telling me that I have 6 chlorines. If you put it on the top, you're saying that you have a charge associated with it. And since you just put 6, I would assume that would be a 6+ charge.
Oh, okay.
Okay. So it always goes on the bottom. So anytime that you're telling me that I have so many of it, it goes to the bottom when you're talking about that formula. So you're telling me for every 1 iron, there's going to be 6 chlorines for that compound. Okay. Questions? Concerns? Cockroaches?
Dr. Henry, I have a question.
Okay.
So when you write down your ionic compounds, your cations have to go first and then your anions?
That is correct. You always put your cation first and then your anion.
Okay.
Good observation. Any other question?
Nope.
So just think about it. You always want to get the good news first before you give bad news. The project's done, but it blew up, right? Good news first. You're like, oh yeah, all right, project's done. And then you give them bad news. Okay. Let's see. So we're talking about Lewis dot structures. How confident are you on your Lewis dot structures? Like 150% confident?
Could use some practice.
Need some practice?
Mhm.
Okay.
Yeah, I agree.
Need a little bit of practice?
Yeah.
Okay. So did you guys have some answers? And we're going to do Lewis dot structures of these over here. So these aren't covalent bonds, so they really don't form true Lewis dot structures, right? They're ionic bonds. So what they're going to do is aluminum we're just going to write that as aluminum plus because it's gotten rid of all of its valence electrons, right? And then nitrogen minus
Oh, I get it. Oh,
is only going to have, fix this.
I get it. I get it.
Nitrogen is going to have 3 minus, is going to have 8 electrons around it. I can draw my electrons. We put it in brackets, and now it has a 3 charge, negative 3 charge. Okay, so then that's what you would draw. Pretty simple.
So, but doesn't nitrogen have because it has 7 protons, right? Shouldn't it be 7 instead of 8?
You tell me. So does nitrogen have 7? You said nitrogen has 7 protons. Are we talking about protons? Did anybody mention anything
Oh
about
no, we're
protons?
talking protons.
We're talking about electrons, right? Because we're talking about valence electrons, right? So then how many does valence electrons does in -3 have? So why did it want to get to -3 in the first place?
Oh, it's because it's three steps away from neon, right?
That's right. It wants to be a noble gas. And all
Yes.
noble gases, except for helium, have 8 electrons surrounding them, right? So nitrogen 3 minus now has 8 electrons surrounding it. So it's like helium, right?
Oh, okay.
And so this is how you would draw the Lewis dot structures for ionic compounds. Pretty simple, not too complex. Now let's look at this one. This one's going to be a little more complex, and we haven't really talked about when we start talking about branching type of molecules, right? So I'm going to give you a hint, but let's start off with something pretty simple. Let's start off with this guy. What do you think he's going to look like?
I kind of did it.
You did the,
I did that one.
you did the methanol, this one here.
Yeah,
methanol.
I did. So I just put C with a, what do you call those lines again? I just can't remember the name. Is it just a single bond?
Okay, we would call it like bonds, yes.
Okay,
So
so I put.
why don't you draw
like,
why don't you draw what you put up? That'll be the easiest, and then you can explain it to me.
Okay. I should have just been quiet.
No, it's okay. You shouldn't have been quiet. It's good. You want to participate. It makes you a better student.
I don't know if I did this correctly.
It's okay.
So I'll
It's
just do what I
learning
drew.
together.
Okay.
Like I say, we learn more from not getting the answer right than getting the answer right.
So here, here, and here would be the placements for hydrogen. And then here would be for, oh wow, that is terrible. I'm sorry. That's supposed to be oxygen.
Okay.
I'm gonna draw that again. So that's for oxygen. Wait a minute, what am I doing? Okay. And then there's 2 little dots here, here, and below. Because in total, oh, I forgot to tell you the math part. So there are 4 hydrogens and one of, so what I did was 4 plus 3 parentheses 1 plus 6 plus 1, and I got 14 electrons.
Mm-hmm.
So I have to write that down too.
You should probably write that down somewhere so everybody would know.
Okay. And these are all the placements for the 4 hydrogens
Okay.
and all of these bonds. And then let me write down the, so 4 plus 3 plus 6 plus 1 equals 14. And it'll equal 14 valence electrons. So if you guys are wondering 14 of what, so each bond equals 2 valence electrons. So I have 2, 4, 6, 8, and then for oxygen is 2, 4, 6, 8, and they're both now, I believe, octet now as well.
Okay. So good job. The structure is correct. Okay, so but I have questions though, right? Maybe you can help me out, but if not you, somebody else. You did the hard work, so we'll see if somebody else can help us out here with this. Okay, so I see the number of total electrons that you have. And so you did the counting. So you said there's, let me do my formula. So you said that there's 1, so that's 2 here, 2 electrons here, 2 electrons here, 2 electrons here, 2 electrons here. So that's a total of 8 electrons around carbon. I saw that. So there's another 2, there's another 2. So altogether that is, what, 12? And then that's 14. So I see 8 around here. I see 8 around oxygen. So why does hydrogen only have 2 around it? Anyone other than David, since he did the heavy lifting.
Because hydrogen can hold up to 2 valence electrons.
Okay, so that's the max it can hold? Is that what you're saying?
Yes.
Okay. Okay, so would I ever expect anything like this? Would I expect anything like that?
No,
Okay, so why doesn't that work?
because your hydrogens don't balance out with 8 valence electrons.
Okay, so my hydrogens don't balance out with 8 valence electrons?
Right.
Okay, but is that the only reason why this doesn't work? There's not 8 valence electrons over here with hydrogen either.
Because some of your hydrogens are maxing out on their valence electrons.
Oh, so what do you mean by maxing out?
So like, you know the hydrogen, the 2 hydrogens that are between the C and then to the right of it, the H, like those 2, like they have 4 valence electrons, like, or that structure is telling us that there's 4 valence electrons in those hydrogens.
And is that possible?
No, because they can only hold up to 2 valence electrons.
Okay,
Like,
so they can only hold 2 valence electrons. So hydrogen can never be a center atom. Never, ever be a center atom. So if I see this, right, I'm going to dock you, instead of just that -1 you would normally get, I'm going to dock you -2. Okay? You guys get that?
yes.
Okay, good. Everybody else get that?
Yes.
Yeah.
Okay. So it's good that Selena gets it, and I think there are 3 other people. So everybody else is going to do it to see, test my gumption. Is that my understanding?
Still trying to figure out how to get 14, that's why.
Yeah, and the other thing is that you got to get 14. So yeah, this definitely doesn't work in many ways, right? Okay. So what about this guy? You guys see the CH4 on your screen?
Mhm.
How would we do that? Let's see, David did one. Who's going to volunteer? Or do I need to volunteer somebody?
I can do it.
Okay, Selena?
Okay, so
I know now. I know how to get 14 now.
but Dr. Henry, it's just for CH4, right?
Yep.
Oh, okay.
Oh, okay.
Yeah.
Okay. So does that meet all of the rules?
Yes.
Okay. So who's going to do water for me?
I can do it.
Okay. Okay. Everybody agree?
Oh, I see. Yes.
Okay. So since Siobhan, since you're seeing, I want you to do nitrogen.
No. Okay. It's just because I missed yesterday, so I was trying to like catch up
Yeah.
and it's not working out. Okay, I could try.
You try. I mean, that's the best way of learning.
Okay, so can you help me talk through it?
Yeah. We can talk through it.
Okay, so nitrogen, we have to get the number of valence electrons, right? So that's
Okay,
1,
yep.
2, 3, 4, 5.
Okay,
But then we're gonna times 2, right? Because it's N2.
okay.
So then that means we have 10 valence electrons.
We have 10 valence electrons.
Okay, I don't know how to draw the structure. That's as far as I've gotten.
Okay, so how many nitrogens are we working with?
2.
Okay, so let's go ahead and put our 2 there, right?
Mhm.
Just put our 2 nitrogens down. We have 10 valence electrons, so it has to have a total of 10 around it, around all of that whole complex. So the
Okay.
question is, this here represents 2, these are 2 electrons being shared, that line over here. Okay,
Right.
so we need to find a way of showing that how many electrons are going to be shared between the 2 nitrogens and how many of them are going to be what we call lone pairs. These are called lone pairs.
Okay.
Okay, so they're not shared between the 2 atoms. Here, it's not shared between hydrogen and oxygen.
Oh, I see. Okay.
Okay, and then the goal is to try to get it so that each of those have 8 electrons around it. So if you count over here, that's 2, this is 4, this is 6, this is 8. So oxygen has 8 around it. Hydrogen is a special case. It can only have 2 around it at the most. So that's the reason why this guy only has these 2 that are being shared, so that has 2 around it.
Mm-hmm.
Okay? So if you look here at carbon, it has 2, 4, 6, 8. So your goal is to reach your octet. That means having 8 electrons surrounding you. Okay? So either you're going to share those electrons or you're just going to have them to yourself. So here they have 2, this has 2 pairs that are being shared. So that's 2, 4, 6, 8. Okay? So we need to figure out how many of these electrons need to be shared and how many need to be lone paired to have a total of 8 around each one of those nitrogens. So what do you want to do? How many lines do we need to draw?
We do. I just get confused. Okay, because there's 10 valence electrons, right? But we need.
We have 10 to work with. So let's just put them anywhere right now, and then we can move them around as we go. So let's put 1 here, and try to put them in pairs. It's always best to put them in pairs.
2, 4.
And so we'll start with 1 line here. So that's like 2 right there.
8, and then 10.
That's 2, 4, 6, 8, 10. Okay. So does this nitrogen have 8 around it?
2, 4, 6, 8. Yes.
Okay. Does this nitrogen have 8 around it?
No.
No. Okay. So we know that that isn't going to work. So what we can do, we can take this nitrogen. We can take these lone pairs and share them between the 2 nitrogens. If I do that,
a triple bond, right?
Oh, okay.
So if I do that, well, this will be a double bond. Let's start looking at that first and see if it works out.
Because we're going to pair them. Okay.
Oops. Okay, so then that's how many? That's 2, 4, 6, 8, 10. So how many electrons do we have around this guy?
2, 4, 6, 8.
8. And then what about this guy?
2, 4, 6.
So does that work?
No, because there needs to be 8 around both of them.
It needs to be 8 around both of them.
Oh, okay.
Okay, so then let's take another lone pair and put
another line.
Put it between the 2. Yep. So then we have okay. So now let's count those.
So 2, 4, 6, 8. Oh, I see. 2, 4, 6, 8.
Okay, so they both reached their octet. They're happy. That's going to be your structure.
Okay.
Piece of cake.
I don't know if we're there yet, but better.
Okay. Okay, do I have a volunteer for carbon dioxide?
Dr. Henry,
Yep.
I am so lost, and I'm gonna be completely honest.
No, that's good.
I'll-
I prefer you being honest. So what are you
Um,
lost about? Tell me, where did you get lost?
I'm kind of like, I'm lost about everything. So I don't know, maybe can I do carbon so I can get a better understanding, or can you help me do it?
Yep, carbon dioxide, you mean.
Okay,
Yes.
thank you.
Okay, so let's do carbon dioxide, CO2. David, I'm gonna erase your answer here to give us a little more room to work. Erase my answer, give us a little more room to work. Okay, Jamie.
You know how she was doing nitrogen? I was so confused because I was like, how does she ended up getting 5 and then 2? So I was like a little confused with that.
How many nitrogens are there, Jamie?
In total, 7.
Yeah. No, not protons, nitrogens. In N2, how many nitrogens are in this?
2.
2.
2. So we have 2 nitrogens, right? So that's where the 2 came from.
Okay.
So, and how many valence electrons does nitrogen have? Let's look at the periodic table.
Okay. Don't get mad at me.
I'm not getting mad at you. Don't take it as me getting mad at you. I'm just
Okay.
talking firmly. Don't take it as me being mad at you. Don't be sensitive.
Okay. No, because I'm trying. I just want to, I want to understand it.
No, it's okay. And I want you to understand it. That's why I'm glad that you stopped me, because you're not, if you don't understand it, there's probably 5 other people who don't understand it. Okay? And we're trying to get you guys all to the same point.
Okay.
Okay, so nitrogen is right here, right? So the easiest way to do it is look in that same period and count back. That's going to tell you your number of valence electrons, but just use only the S and the P, right? So how many electrons are in period 2 in the P block that nitrogen has?
P block?
P block. Right now, just look at the P block.
5.
Nitrogen has, in the period 2, it has a total of 5. Okay, Jamie, this is what I want you to do. Circle nitrogen.
Hold on. I can't. Are you like trying to share the periodic table? Because I can't see it.
Oh, maybe that's,
Yeah, I'm sorry.
that's my fault.
I'm
Hold
also.
on.
I'm just seeing the white screen.
Yeah, hold on. I was trying to share the periodic table. It looks beautiful on my screen. Can you guys see it now?
Oh, there.
Okay, so we have the P block. Show me where the P block's at, Jamie.
Okay, hold on. Let's see. Right here.
Okay, okay.
Sorry.
Show, is it, when I say the P block, are you saying right here as in right at neon? Or are you saying,
No, it's this whole section right here. Yeah,
so
hold
from
on.
5 to 10 in that case, right? So that from 5 to 10 in this whole section. Is this what you're saying?
Yes.
Okay. Okay, so that's the P block. So circle where nitrogen is at on the P block.
Right here.
Okay. Now circle nitrogen. Okay, so now what I want you to do is counting only the S and the P block. So where's the S block?
Right here.
Okay, so counting only the S and the P block in period 2, starting where nitrogen is at, count backwards. How many electrons is that?
That's 5.
That's 5. So
Okay.
that represents the valence electrons for nitrogen.
Okay.
Okay, so it's always just going to be, when we look at the valence electrons and we're talking about things that are over here that are in the P block, we're going to count back 1, 2, 3, 4, 5, and that'll tell me my valence electron. So for
Okay.
instance, fluorine, How many valence electrons does fluorine have?
It's gonna be 7.
7. What about boron? How many valence electrons does boron have?
3.
Okay. What about beryllium?
Where is beryllium?
Oh, 4 on it. 4, okay, 2.
Is it 30? It's number 35, right?
Beryllium?
Oh no, what is it? I can't. Oh, it's only gonna be 1.
Number 5, yeah?
Beryllium. I'll say it again.
Is it 2?
2.
Mm-hmm.
Okay. Tellurium.
Can you repeat that? I'm sorry.
Tellurium?
Tellurium. Okay, that's I found it.
What is it? T?
It's Te. That's right.
1, 2, 3, 10, 13.
16.
How many?
I don't know, like I was trying to count fast.
So remember what you're counting.
16.
Oh, so we're only counting the S, right? The S block
Yes, and the what?
and the P block.
Okay.
Oh,
Okay. Oh yeah, because we don't count the D block, right?
That's right.
Don't count these.
So it's gonna be 6.
Okay. So it's going to have 6 valence electrons, right?
Okay.
So those are the electrons that are going to be involved in bonding. Okay.
Okay.
And so it's only the electrons in the outermost shell that are going to be involved in bonding.
Okay.
Okay. It's very rare that you'll have to use the D block. Okay.
Okay.
Okay. So that's going to be
Okay.
important. So you always want to figure out the number of valence electrons you're working with. So for instance, let's say we are doing, let's do tellurium. We're going to make a compound of tellurium that is diatomic. Tellurium is not normally diatomic, but we're going to do some crazy stuff in the lab. We have Te2. Okay? So that's the one you're going to work on right now.
Okay.
Okay. So how many valence electrons does Te have?
6.
6. Okay, so let's go ahead and write down 6 valence electrons. And how many Te's do we have?
How many TEs do we have?
Yeah, how many Te's do we have if we have Te2?
We have 2.
We have 2. Okay, so we have 6 plus 6 valence electrons. So that's a total of how many valence electrons?
It's gonna be 12.
So we have 12 valence electrons that we're working with.
Mm-hmm.
And we'll put a VE, okay? So we have 12 valence electrons we're working with. So show me your magic.
See, I don't know how to put it together.
Well, it's just trial and error. So let's just put it next to each other, right? Because that's what you would do.
Okay.
And then put lone pairs. Lone pairs are meaning 2 electrons together in there. So put them in there and see what you can get until you can get something that works out.
So right. I don't know if I'm doing this right.
That's right.
You know how you say like you know how I'm trying to, you know how nitrogen had the 3 pairs? That counts for each one, right? I'm a little confused. I don't know how to write this out. Can someone help me, please?
Do you want me to help her?
Yes.
Yeah.
Let me see if I'm.
So right now you have 4 electrons up there. We need 12 that we need to circle it, right? So you need to put 12 around that whole thing together. So some way you need to arrange it so there's a total of 12, right?
Mm-hmm.
That's always the best way of starting. So at the same time, Jamie, you've given up. Go ahead and start. While she's doing it, you want to do it as well. So go ahead and do it.
Okay.
You both should be able to write on my screen. So put 12 anywhere that you want to, long as it's surrounding both telluriums.
Dr. Henry?
Yep.
So for
So we don't need to try to equal the 8. We have to try to equal 12.
No, you need a total of 12 electrons that you're working with. You want to get 8 around each individual tellurium.
Okay. Okay.
Okay? So while you guys are doing that, I'm going to write tellurium over here myself. I'm going to show you 3 different ways, and I want you to take a look at them. And I'm going to have, Rachel, you're going to count the first one for me.
Okay.
Oh, I don't know what I'm doing. No. So the equal sign, is that like the threads that connect them together?
That's bonds. So each of
Oh,
those
okay.
represent a single bond. So that's sharing of 2 electrons together. So a line is going to be the same as having 2 electrons. You're saying those 2 things,
Oh.
tellurium is sharing this. So this is only for covalent bonding. That's when you're sharing electrons.
Okay. I understand it now.
Okay. Okay, Rachel, do me a favor. You see this one here? This is A. This is B. And this is C. So Rachel, what I want you to do is count how many electrons are around each of the telluriums.
Okay.
Let's see. Aaron, I want you to do the same thing for B. And then Jamie, I want you to do the same thing for C. I want you, well, actually, tell me how many total electrons that we have there. And then tell me how many electrons are just around each of the telluriums.
Okay.
Okay.
So in total, there's 12. Oh.
Yeah, I want you to actually do the counting, right?
No, I did. I counted that. So it's for each one. It's so I know this is 1, 2, this 3, 4, 5, 6, 7, 8. Oh no, hold on. Did I do this wrong? So it's 2,
You're
4.
doing C, right?
Oh no, yeah, I know what it is. Sorry, my bad. Still here.
Okay, Jamie. So let's start. How many total electrons do you have? Now, I didn't say
Oh.
lone pair electrons. Even if they're
Oh.
sharing, you want to count the ones that are being shared as well too, because you want to make sure
So-
that it fulfills its octet.
So
Okay.
it's 10, right?
So it's a total of 10. Yes.
Yeah.
So, and how many
Sorry.
are we supposed to have?
We're supposed to have 12. I'm sorry, I was saying 10 the whole time. I just forgot that I turned off my mic.
Okay.
Yeah.
Okay. So altogether, there's a total of 10, right?
Mm-hmm.
So how many does it have around each one?
It has 2.
No. Total around each one. You even can count the ones that are being shared. Do you understand? Okay, Jamie. Right here. The ones right here in this block. Let me see. You see the box that I made? How many electrons is that?
I think she left.
She left?
Said she left on, I got like a little notification on top saying she left.
Oh. She probably got dropped.
Or you scared her away.
Or I scared her away.
I think both options are fair.
Okay, who's going to answer my question? How many are being shared?
There's 6 in there, right? Oh, that little box.
6 that are being
There's
shared.
there's a total of
So-
6 being shared. Yes. Okay. So then we know that this isn't going to work because there's a total of 6 being shared. Well, first off, there's a total of 6 being shared, and we have a total of how many altogether?
12.
12.
So we should have 12, but how many do we actually have here?
10.
10.
We have 10. So we know that this is going to be the incorrect answer because there should be a total of 12. So we know that this one wouldn't be correct, right? So this one is wrong.
That's why I keep wondering why you put 10 on there.
Yeah. Well, I just wanted to show you that it's wrong, right?
Oh, okay. I thought like,
So the one in the middle, right? Aaron?
Yeah,
Are you
we
there?
we have a total. I wrote something there. I don't know if you saw it.
Okay.
We have a total of 12 electrons and
So-
4 each surrounding each.
No, so you also want it, when you count the ones that are surrounding it, you also want to count the ones that are being shared, right? So
Yeah.
like each of the tellurium have how many electrons surrounding it. So you include the ones that are being shared.
Oh, okay, okay.
So your goal is to have 8 around it.
Yeah.
Okay?
So we need 8 around each one.
Yep.
Yeah.
And total to equal 12.
it's the right answer.
Okay? And Rachel, are you there?
Yes.
Okay. So you said there's a total of, I can't read your handwriting. Is that 18 or 16 or?
8 for the first one.
There's 8 for the first one?
Okay, so then that middle one will still be counted for the sixth one, for the second one also.
That's right. You count it twice. You want to count as if, because remember, they're sharing them, right? So that means it gets it some of the time and the other one gets it some of the time. So they're literally sharing them. So you want to count them.
Okay. Okay, sorry. So that doesn't look like an 8. So okay, so it's 8, 8, and then so total 16.
Yeah.
Dr. Henry?
Yep.
I'm so sorry. My computer just completely shut down. So
I
I'm on my
thought you
phone
quit.
now.
But they were making bets. They thought I bullied you out of the classroom. I was going to get reprimanded, you know.
No. It's just like I've been having issues with my computer.
It's okay.
Hey, Dr. Henry,
Yes.
you know the A? So 246, A, 246, A, you want 246, A, 10, 12 is 14 though, right? It's not 16.
That's
Is
right.
that total?
Well, see, that's 2 right here. So what we'll do, let's circle them. Let's go through and circle them. And we'll, as we circle them, we will count. So that's going to be 2. Can you see my yellow?
Yes.
So that's going to be 2. That's going to be my first 2. So we're going to
Yeah.
put 1 by it as well. So put a 1 by it. Okay.
Okay.
My next 2 is right here. So we're
Yeah.
going to put 2 by that one. My next 2 is going to be here. We're going to put 3 by that one. My next 2 is going to be the 2 that is being shared, right?
Yeah.
And that's going to be 4.
Two.
My next 2
Oh. Same.
and that's going to be 5.
Right.
My next 2 that's going to be 6. And my last 2 that's going to be 7. Okay.
So,
So we
it's
have
14, I know 16, right? Is it?
2 times 7 is 14.
Yeah.
Okay.
So, and we're supposed to have how many valence electrons around it?
12.
We're only supposed to have total of 12 valence electrons, so 12 VEs, okay? So we know that this one is also wrong because it has too many electrons around it. Even though, if you look at it, if you count this tellurium, how many electrons does this tellurium, we'll call this tellurium A.
8.
We'll call it tellurium A. How many does tellurium A have around it?
8.
8. And then how many does tellurium B? This is tellurium B. It has 8, right? So even though it obeys the octet rule, it screws up because it has too many electrons. Because we're only supposed to have 12.
12.
We have 14. You can't just magically get 14 electrons, right? What you put in is what you must get out. So you can't just, oh, I'm just going to throw extra 2 in there. So that's also wrong.
So the answer is B.
So the answer would be B. That's correct.
Okay, Dr. Henry?
Yep.
Do you see the one in the black?
Yes.
Okay, that one is correct too, huh?
That is the only one that's correct. So this one is wrong. This is the only one that's correct.
No, I mean on the left.
The one that she did.
Oh, this one here in the black? Yeah, that one is correct. Yes.
Okay then.
Yeah.
Yeah, that's exactly the same thing as here. So where you put your lone pairs, it doesn't matter. They could go top and bottom, or they could go side and bottom. It doesn't matter where you put those, really. Okay?
Okay.
Simple?
Yes.
Okay, so now let's make it hard. Okay, so now you have nothing to compare to. This is what you're going to be working on. I'm going to give you guys a couple of them to work with. But let's talk, we'll do CO together. CO2.
Okay.
Okay. So we have carbon dioxide, right? So there's a couple of rules that we need to remember. And then I'm going to tell you the quick way of doing it rather than the long way of doing it. And there might be some exceptions, but overall, we'll get it to work out, okay? So first off, carbon likes to be in the middle. Remember, carbon's a whore, so it really likes to be the center of attention. So it's, in most cases, will be the center atom, okay?
Okay.
So how many valence electrons does carbon have?
Carbon has 4.
Okay, so carbon has 4. And each oxygen has how many?
6.
So 2 times 6?
12.
So we add together, all together, we have how many valence electrons?
16.
Oh, 16.
So we have 16 valence electrons.
Mm-hmm.
So that's what we're working with. So now what did I just say about carbon?
She's a whore.
Needle.
She's a whore. Why does it have to be a woman? It could be a guy.
Oh, I guess so. Sorry.
Guys can be whores too. She's such a sexist. Okay, so, and since she's a whore, or he's a whore, then where are they going to be at?
In the middle.
So then the oxygens are going to be on both sides.
Okay.
Okay. So we have 16 electrons. Let's just put electrons anywhere. But let's try to put them in pairs.
Okay.
Okay. You guys see my 16? Is that 16?
Mm-hmm.
Okay. So I have my 16 electrons. So the way that they're looking right now, we want to start moving things around. So I'm going to circle them in a different color. So we want to fix it so that everybody has 8 around it. So these two, where should I move this so that this guy has 8 around it? Or this guy?
Those two.
The middle.
So move it in the middle?
Draw a line.
Okay. So let's do that.
Yeah. Yeah. Yeah, the middle.
Okay. Move it in the middle.
With a light though, doctor.
What was that?
With that light though.
That didn't work. Hold on. See if I get this to work for me. Okay. Oops. Okay, so I got them in the middle. So, but then that only leaves how many here?
2 only.
2 only, right? So I have 2, 4, 6. So does that give me 8 around my hydrogen? I mean my oxygen?
No.
No? Okay, so maybe that's not a good idea. And then I have a total of 8 around carbon, but I don't have any bond going on here. So what if I move these, the ones here, over here? Would that help me?
No.
No, it's not gonna help me over here. Okay, so what do I need to do?
You move a 2 only.
Move 2 more over it so they're sharing?
No. You just make a bridge. Draw a line.
So how about, let's say we move these right here, the ones that are circled in yellow.
No.
Okay.
Nope.
Come on. Oops.
I cannot see no more.
Okay, so then that gives me a total of how many? Let me fix my dots in there.
Dr. Henry?
Yep.
I think I figured it out.
Okay. Hold
Can
on,
we
David.
Okay.
Okay. So I got a total of 6 in here. 6 electrons that are being shared there, right? So this gives me 8 around the oxygen. Does that not give me 8 around the oxygen?
Yes, it does.
It does. Okay. And so right now I have 8 around this oxygen. I have 8 around the carbon. Is that going to work for us? Because there's no bond between this other oxygen.
Oh, I see.
So maybe I should move these so that they'll be shared between that oxygen.
Mm-hmm.
Okay. So now let's try again. So now, and I'm just going to draw a line once we have our pairs formed. So does that work?
2, 4, 6, 8.
That worked too.
Yeah.
Wait, but there's not 2, 4, 6. Oh, never mind. Just kidding. 2, 4, 6, 8. Oh, okay.
Play Pac-Man now.
Okay, so count total electrons.
2, 4, 6, 10, 12, 14, 16.
No, that's the
2,
only way.
that's 4, that's 6,
That's 8.
that's 8, that's 10, 12, 14, 16. So 16 valence electrons.
Mm-hmm.
Does oxygen have 8 around it?
2, 4, 6, 8. Yes.
Does carbon have 8 around it?
6, 8. Yes.
Does oxygen, the other oxygen, have 8 around it?
Yep.
Yes.
Dr. Henry, I have a question. So it doesn't matter if the bond you have on both sides are not equal.
It doesn't matter. No, they don't have to be equal.
All
In
right.
most cases, they're not.
Okay.
Sometimes they are, sometimes they're not.
Okay.
The goal is, remember, the goal is to have octet. Try to reach your octet. So you want to try to the best of your ability to reach your octet and to use the electrons that you actually have. You can't just add electrons in just to make it work.
All right.
Okay?
Okay.
Piece of cake?
Dr. Henry,
Yes, sir.
how about you move the, the O, what's it called anyway? The oxygen, the 2 from the first one to the last 2, and then you make like 2 beach on each other, and so they make it look better, like like two line in the middle, and then have 4 on each side, so be 8 too, right? Because you move 2 from oxygen. For the first one, you move 2 to the last one, become 4. They have like 4 on each side, and then after that you count like you take one line in the middle of the carbon to the first one, so you have 2, 4, 6, 8, and 2, 4, 6, 8 is the same, right?
Yeah, so yeah, there's 2, 4, 6, 8 around carbon. There's 2, 4, 6, 8 around oxygen. 2, 4, 6, 8 around this oxygen. So it works out.
Okay.
So is there another way that we can do it?
Yeah.
Yeah?
Yeah, that's the way I talk about.
So you're saying, that's what you're saying. You're saying that I could do it another way.
Yeah.
Oops.
see this one. Yeah, this way. Yeah. No water.
Okay, does that obey the rule?
Is there
So
water?
that's,
It's 8.
it has 8 around it, yes.
No.
So that's 1, that's 2, that's 3,
4.
yeah, 4, I'll fix that in a second. 5, 6, 7, 8, so that's a total of 16.
Yes.
Okay. Okay, total of 16. So yeah, this one works as well too.
No, the first one looked better because I have 3 lines.
It looks better because it has 3 lines.
Yeah.
So now here's the question. Right? So technically these guys would be considered what we call possible resonance structures of each other. Meaning that, and I'll talk about this a little bit more, meaning that you could have multiple possibilities of the structure that you're going to get. Right? And so in this case, if you were in my 1A class, we would go through formal charges to sit there and figure it out. And if you did the formal charges, you would actually figure out that this is the more preferred structure than this one. Technically, they both can exist, so they would both be correct for what you guys are doing at the level you're at. But this one is more preferred.
Why?
Well, one thing, if you, as I said, the formal charges, so if we had split these guys up, it would be as if you had your 6 around here. It'd be like even, it'd have even pool to it.
Oh,
This one has a more of a pool than this guy would.
Oh,
Okay.
2 more.
Yeah. Okay.
Yes.
Can I ask a question, Dr. Henry?
Yeah.
For the CH4, should that have 8 valence electrons or 10?
CH4, if we did CH4. So carbon has how many valence electrons?
6.
Carbon has 6 valence electrons?
4. 4.
4.
Okay, never mind. I just did my math wrong. Never mind.
Okay.
Thank you.
Yeah, so you don't want to sit there, and this is often what a lot of people do. You take in all of the electrons instead of taking just the valence. We only want to look at the valence when we're talking about bonding and when we're doing Lewis dot structures. It's only valence electrons. Are you guys having an earthquake?
Yes.
Oh, you guys.
Is there an
Yes,
earthquake
we
or am I
are.
tripping?
Yeah. I just got-
No, it's happening.
They're moving right now. Oh.
Oh, yeah.
Yeah.
Where is it? Where are you guys at?
Look at my clothes. I'm moving.
Hanford.
I'm in Visalia.
I'm in
Oh my
Kermit.
god, I'm feeling it. Oh my god.
Okay, yeah, it's hitting fireball now.
Oh my god.
Still moving.
Oh, that makes me feel
Is
really
it
good.
really bad over there?
I come back later.
Are you guys still feeling it? You still
Everyone's
feeling the
having an
shock?
earthquake.
You guys know that?
Let me go check on my kids.
Okay,
I'm gonna check out my siblings.
so let's go. Let's take a 10-minute break. We'll be back.
Okay.
Okay.
Okay,
Dr. Kenny, I have a question.
I may have an answer.
The CL, you know, like they have 4 of them here, so we use 8 times 4.
So you said you use 8 times 4?
Yeah, get 32 from
I
it's a
would
4
use 8.
time, right?
How many valence electrons does Cl have?
8.
Are you
1, 2,
sure?
3, 4, 5, 6, 7.
7.
Yeah.
Okay. So it has
See?
7. So 7 times 4. That is correct.
28. 28.
Yep.
That's
Everyone
a
back?
lot.
Is everyone back?
Yes.
Yeah.
Yes. Okay.
Yeah.
So I've written 1, 2, 3, 4, 5, 6. 6 covalent compounds on the board. What I want you guys to do is to get in groups, draw me the Lewis dot structure, and then we'll talk about it. Okay, you guys can do that?
Are you gonna put us in groups?
Yes.
Okay, good.
That can be.
Are you ready?
Yes.
What are we supposed to do with these ones? The same thing?
Lewis dot structure.
Okay.
Okay. Okay, so since we have all you guys have completely done it. So each of you guys are going to be responsible for showing me one Lewis dot structure. Let me get my. So let's see, Matt, you're going to do the first one, which is ammonia.
Just annotate on the screen here.
Yep.
No.
Okay, I think I'm done.
Okay, that looks good. Okay, let's see. Let's have the next one, which is chloroform. That's CCl4. So that we're gonna have Karina. You want to do that one for me? Yes, that's right.
Stronger with this.
Hey, Jessica,
Yes,
they put you to work.
they put me to work.
I said, I may put you to work.
Oh, that's fine.
Okay. I need to go and deliver these calculators and handouts because I thought I was going to be done a little bit earlier today than I was. So, do you mind? Good job, Karina. Okay, Aaron. Let's have you do the next one. H2S.
The H2X?
Yes.
All right, I'll try. Ooh, wow.
So do you mind going over the rest of with them?
No, I don't mind.
Okay. I also need to give you power
Okay.
because I need to run. And then the rest of the class is going to be coming out.
Okay.
Okay. So tell them I'll contact with them tomorrow, and then I'll see some of them in the spots today. So.
Okay.
Okay.
Sounds good. Yeah.
So do you want to share your screen?
Yeah, let me share mine.
Okay. Hold on. Let me let her finish, and then.
I'm actually finishing it, Dr. Henry. She wrote in the chat that she wasn't able to put 6 dots around each one, so I'm just doing it for her.
Thank you.
Dr. Henry, do you want me to do the next one?
Yes. But let me get Jessica's screen up so that I can make it to places I'm supposed to be on time.
Okay.
Okay.
I think I am done.
You are done. That is correct.